This conference will now be recorded.
Okay, let's get started. So before we get started, I know I know most of you might know my name. If you don't know, my name is Kiran, and I have about 10 years of experience in DevOps and you know um, site reliability engineering roles. Site reliability engineering is very similar to DevOps in many ways. Uh, okay, so again, so before we start this course, let me welcome you all. Thank you for joining. We'll have a nice ride discussing DevOps technologies, generally how do IT operations work, and with emphasis on automation, and particularly we are going to learn Azure and how do we automate stuff on Azure and all these things. Okay. So before we begin, again, I'll tell you the same things. Every day we begin from 7 to 8. Sometimes I might take up to 7:05 or 7:10 because I have a class between 6 to 7 and I don't want to leave some topics in between just because it is 7 o'clock. So there might be a little delay here and there, 7:05, 7:08-ish, not more than that, in the morning. Okay, we will continue up to 8:15 or 8:20 based on how our topics are progressing. Okay, and we have classes from Monday to Friday every day, every week. We may go up to 10 to uh, 12 weeks is the course duration. And regarding the fees and everything, you can speak to my colleagues in Career IT, Lakshmi, and others. Okay, um, so that's where we are. And again, there is no specific restriction on when to ask questions. You need not wait till the end of the class or the next day to ask questions. Just stop me whenever you would like to um, ask a question, and I'll take your questions, but not exactly interrupt me. I mean, if I'm in the middle of the sentence, maybe please wait for me to complete, and then you can definitely ask. Um, okay, and let me take a minute to talk about my methodology. How do I teach, or what tools I use to teach? Okay. Mm, so pretty much our classes are going to be hands-on. Okay, less of theoretical, more of hands-on, right? But that doesn't mean we don't have any theoretical sessions. We do have theoretical classes. We have to understand some theory as well. We have to understand the concepts behind what you're doing. Okay, so not just starting 1, 2, 3, 4 and these are the steps, do it. That's not how I want to do it. I want you to understand what we are actually doing as well. Okay. um, so mostly I use these tools. Okay, so I use this text editor. What's today's date? 9th November, right? So as a for the text editing or writing any nodes so that you could see I use this Sublime. Okay, sometimes maybe Atom, but yeah, this tool you will see on your screen. My browsers, I use Firefox for my presentations and opening the cloud applications like Azure and other things. Okay, and Chrome for connecting to GoToMeeting because Firefox doesn't support GoToMeeting somehow. Uh, the reason I'm telling you is because these are the screens you see on my computer when I'm sharing my screen. So you need to understand what I'm using these for. Okay, so you're not confused. And I use, because we are going to do a lot of Linux system. I mean, we connect to Linux machines and we do automations. So I use my terminal. Okay, called as Terminator in this case. But yeah, I use my Linux terminal to connect to Linux machines and also run the commands. I myself am using a Linux machine. Okay, my operating system is Linux operating system. Even if you're using Windows machine, that's fine. All that you need to do is install a tool called as git bash. Okay, go to git-scm.com on your browser and download Git for your operating system, Git for Windows. Okay, if you have a MacBook or a Linux operating system like Ubuntu or something, you don't have to install anything. You can directly use the terminal. But in case if you're using Windows, you need to install git-scm, and go to git-scm.com and download the Git for Windows. And it also comes with a tool called as Git Bash as part of your Git toolkit. It comes with this command line tool called as git bash. It looks very similar to your command line, but it is much advanced, and it gives you the option to connect to Linux machines and do some automation as well. Okay, what else do I use? Yeah, these are the things I primarily use. You'll see on my screen. Okay, and for any presentations, I use Google Drive and Google Slides. Okay, for example, this is done in Google Slides only. Mm, yeah, pretty much it. And my notes are mostly on GitHub. I'll share those links as we go along. And some of them are on my Google Drive. PPTs and other PDFs and PPTs are on Google Drive. GitHub has some documentation wherever I had to share the links for the not links, the notes for the commands you have to type and all these things. My notes is on github.com. I'll share that with you. Of course, you all also have to will create an account on GitHub. GitHub is not same as Git. GitHub is a web application, a web service. You can log into it and create by going into github.com. Not immediately, it's not required today, but you can do it as soon as possible. It's a free account, you don't have to do anything. Okay. And what tools are we going to primarily use, or what websites we are going to go? Of course, we are going to go to the Azure portal a lot, the portal.azure.com. I told you my presentations and everything are on drive.google.com. So I open this port, and maybe, based on, of course, we do a Google research time to time. So I'll open Google sites. There are, any other, yeah, that's it. Whenever we are learning CI/CD, we go to the Azure DevOps website. Okay, so basically generic websites, nothing in specific. Okay, and I'll also tell you which website we are on when I'm switching to the tabs. Yeah, the reason I'm telling you all this is, when you see a screen, you need to understand what it is exactly. Okay, make sense? Any questions? Okay, and again, as I said, it will be free flowing discussion. You could interrupt me at any time and ask me questions. I'm not very particular that, I have to finish a particular topic in X number of hours or X number of days. Though I would like to finish the classes faster so I can go to next batch and earn more money. But my priority is always, um, you understanding the concepts well, and uh, so time doesn't really matter. I know we are all eager to complete our courses first and give our interviews, but whatever we are learning, it's better if we, you know, get the full understanding of this one. Okay. All right. Any questions before we start about the course, about me, or about anything apart from fees and other things? As I said, duration is not fixed, but you could say anywhere between 10 to 12 weeks. I would always prefer to say 12 weeks is better, like almost 3 months. Okay. Uh, so what is this? November, December. So yeah, unfortunately, we will have too many breaks in December and uh, January as well, Sankranti and Christmas and stuff like that. Okay, yeah, but yeah, let's say end January we will complete our course with all the concepts. And your recordings will be available right after the class. Okay, so if even if you miss the class or there is a network connectivity, because I know, right, virtual learning has some challenges. So even if you miss the class because of some other reasons, or there's no internet, or whatever reasons, you can get the recordings immediately after the same. So most of the time my colleagues at Career IT try to share the links at the same day. Otherwise, the next day you will see the uh, recordings. Okay, can you all hear me? Mic check.
Yes, sir.
Yes.
Yeah, because we are talking about virtual learning, and one of the common things that happens is these network disconnections and stuff. Okay, right. So yeah, recordings are available for you not only throughout this course, but after this course also, if you choose to, you know, join this course. My notes are also available for free, and you're welcome to give me feedback on my notes or anything, and I'll fix that or update that if required. Okay, open to questions now. Next 5 minutes, let's spend on any questions you might have, and then we'll go to our first topic today.
Um, Hello, sir.
Yeah.
So let's like whatever you said, the notes is just like what you're just dictating or you're showing in the class.
Yeah, there is no dictation of notes as such. It's just only for making things clear for you. For example, sometimes I might say something and it might be conveyed as different things. So to make sure the spelling is right or to abbreviate something, I use this one. This is not exactly notes. I would recommend you all take notes yourself, okay, from what I teach. Uh, I would say taking notes on a physical notebook, meaning your paper and pen, is much better than taking it on your notepad. That's what many experts also say. For me also, that was beneficial whenever I was trying to learn, even today when I'm trying to take some notes. So you could do that on a pen and paper, I mean notebook and a paper, notebook and a pen, sorry. Or you could take it on your notepad or whatever tool you're using, right?
Okay.
uh, but I'm not going to dictate notes as such. You can copy notes, or you can understand from what I'm teaching, but no specific dictation or no specific notes. Okay. Again, as
Okay.
I said, there are some notes available. There is documentation available in my GitHub, which I will share after our topics are discussed. Each topic I'll share the link for the particular topic, and you can refer to the notes, the commands, and everything. But there are a lot of things I cover which are not there in the notes, so you might want to take them down while the class is going on. Okay.
Okay. Okay. Thank you.
Yep. All right. Other questions? And also during when I'm discussing a particular topic, maybe I'll also talk about um, certain interview questions or probable interview questions or some versions of interview questions. You might also want to take that down. Again, I'm not maintaining any list of questions, but generally from my interviewing perspective, I also interview for a lot of positions. Um, so what type of questions I ask on a particular topic, or what type of questions you might expect, I'll talk about them. Again, orally, you can take them down while I discuss that. All right, if you do not have any questions, let's proceed to our first topic today. So, yeah, I don't have any presentation as such for the topic. We're going to talk about something very basic, how the applications work. Okay, how do we access applications or services created by someone else somewhere? Okay, so what do I mean by that? Let's say you're accessing Gmail on your browser, or simple Google. Okay, you're accessing Google on your browser. So how does that work? Okay, so for example, there is a website called as google.com. So I enter the website name and hit enter. So from the time I enter the website name and till the time I hit, I hit enter and the page loads. Can someone tell what happens? So from not after the page is loading, but from the time I hit google.com and hit enter to the time the page loads, what happens? Anyone? Come on, there are no right and wrong answers. Okay, we all have our own levels of understanding. We could be, you know, somewhat closer, somewhat far off. That's all right. Okay. And remember, if you don't speak up in my class, okay, how do you speak in the interviews, right? Here you have all strangers. Most of you don't know each other, and there's no problem of this feeling ashamed or something. There is nothing like that, folks. Keep on keep speaking up, and you'll build your confidence. What will happen at the most? You might say something not very correct, maybe slightly incorrect here and there, but that's fine. You'll still learn. Okay, I understand your understand. I'll understand your understanding of the topics, and I can do better. So yes, so take a guess. Doesn't matter from what you hear, from what you heard, and what you read. What happens after I type google.com before the page loads?
Okay, Kiran, it goes to the server and
Hmm.
it can and it sends a response to us to our question.
Okay, so let me open a. Yeah, I use this website as well, draw.io, which will help me to draw diagrams easily. Um, so let's say this is my laptop. Yeah, this is my laptop, and say I'm using Chrome browser, and from the browser I made a request, and you're saying it will go to the server. Okay, let's. Okay, it goes to the server. But the question is, how does my browser know to which server it has to go? Okay, this is the server. Okay, the question is, there are a lot of servers on the internet. How does my browser know to which server it needs to go? That's the question.
It will look up in the DNS.
IP address. IP address.
Okay, so we heard two new terms, DNS and IP. Okay, before we come to IP address, what is DNS?
That's the domain network service.
Domain network, no, domain name service.
Yeah.
Okay, so what does DNS do? Okay, back in the day, right, when we did not have mobile phones and you know all these internet and all that stuff, only we have the telephones, land fixed line, or landlines as we call them. um, so back in the day when we had to call someone, we used to have some books called as telephone directories. Okay, these are huge books with lot of advertisements and numbers of every person that has a telephone connection. Okay, in an alphabetical order for the entire district. They used to publish one, sometimes for entire state also, but particularly for an entire district they used to publish these telephone directories where they have names listed in alphabetical order. Okay, Allu Arvind. Okay, Adivi Seshu. Maybe I'm not maybe I'm not alphabetically correct. Okay, Allu Arvind, Nini, so on and so forth. Okay, so every name in the town and followed by their phone number. Okay, and back in the day we used to have district wise telephone codes as well. Even today we have them for fixed lines. Okay, for example, Hyderabad is 040, Chennai is I think 022 or something like that. Okay, so it's a simple key value pair. What does that mean? Key value pair means you have a name, you have a number. Okay, let's say 2331230. Okay, some numbers like this. Okay, um, so you have name and number like this. So DNS is also pretty much similar. DNS is also a key value pair which stores your website name, or what we call as a domain name, and as someone said, the IP address. Okay, so DNS has the list of all these things, like aws.amazon.com, amazon.com for instance might have another IP address. Microsoft.com. Okay, so you have these IP addresses. So for my browser to go to this server, first it needs to get IP address, because computers understand IP addresses, right? So before it goes to the before it goes to the server directly, my browser will check it within my local system in the cache if the IP address is already stored for this website. Let's say I'm accessing for this for the first time, so it will go to my router. Okay, what is the first connection in my, what is the first hop or first destination in my when I try to connect to internet is my router, right? So it goes to the router. Your router, some of the routers have the capability to store the IP addresses of different websites you access. They can cache the IP addresses. Okay, if it is not available there, it will go to your ISP, internet service provider. Okay, so your internet
Okay.
service provider has something known as uh, a DNS resolver. Okay, so he has something called as a DNS resolver, which basically resolves domain names to IP addresses and sends it back. Okay, what if your domain, your ISP is, for example, if you are in India, it could be something like Airtel, Act, or High Reach, whatnot. You have all these things, right? Vodafone Idea also has a ISP, I guess. Okay, but primarily use either Airtel or Act Cable, or what are the other things? Vodafone Internet, or what I mean Vodafone Idea, or some other things, right? In US it could be AT&T, Verizon, and all these things. Okay, so these people basically from where you're getting your internet, the person who gives the cable to your home. Okay, and then it has a DNS resolver. It should be able to resolve the IP address and send it back. If it doesn't have, what happens then? Okay, so there is something called as a DNS root server. Okay, so every address we might see only google.com, amazon.com, microsoft.com, or whatever the other website. But there is one character that we don't see. It is implied, meaning it is understood that is there. It is called as the root server. The dot at the end is the root server. Okay, so the first request that goes to is your DNS root servers. Okay, so if your ISP doesn't have, your ISP will forward the request to your root server to get the IP address for google.com. Okay, so root server might or might not have the IP address. So it says, okay, you're talking about google.com. So I don't have the IP address, but I know where you can find the IP address. There is something called as top level domains, TLD. Top level domain means all these things are top level domains. The .com, .org, .co.in, .co.uk, .edu. You have everything these days. .tag, .website. Back in the day, it used to have something like .com, .org, .co, .in, .co, .uk, .com, .au, what do you say, country-wise domains, or some specific ones like .edu, .org, and these kind of things. But these days you have all kind of top-level domains, right? You have .website, .me, you name it. You have most of the top-level domains. So since we're searching for google.com IP address, it will send me to .com TLD. Okay, what does TLD stand for? Top level domain. Okay, from root server, the request will be sent to .com. Now .com server says, okay, I know what you're talking about. Okay, but I don't have the IP address, but I know where this person has bought the IP address, domain name from. So if you have to buy a IP address, what happens? So sorry, not IP address, a domain name. Let's say if you want to start a uh, website with the name google.com, can you start a website with the name google.com? Or microsoft.com, can you start a random website? Because you can take cloud instances and create your own um, servers. Can you create a website called as google.com?
No.
Okay, so why not?
URL should be a unique.
URL should be unique. So who controls this one? Okay, so just like how you cannot have whatever vehicle number you want, the there is an RTA which controls, what numbers are assigned to which vehicles. You have organizations called as like IANA, okay, Internet Association for Names and Addresses, and you have ICANN, Internet Consortium for Signed Numbers and Names. I always forget ICANN. ICANN stands for Internet Corporation for Assigned Names and Numbers. Okay, so non-profit organization. It is not a company like Google or Microsoft. It's a non-profit organization which works in which works to maintain all the IP addresses and domain names, and you have IANA as well. IANA stands for the Internet Assigned Numbers Authority. Okay, so IANA oversees the IP address allocation and what IP addresses can be used, whereas ICANN works on both domain names and everything. So these things control what top level domains can have, or what websites can be are already sold out. So when you want to create your website, let's say not google.com, I want to create my own website like kirandevops.com. What do I need to do first? Can I create the website just like that? Actually, I have to buy my domain name from organizations or companies known as Registrar. Okay, so you might have seen the ads from GoDaddy. It's one of the top registrar. You have Namecheap. Okay, uh, you have Amazon.com, from AWS also you can buy your domain names. Okay, Google is its own registrar. So a registrar is nothing but someone who maintains the list of the directory domain names and also sells them. But let's say I created a website on GoDaddy.com. I bought my website. When you buy a website name, that doesn't mean you have a website, but you can use this kirandevops.com to host your website. Okay. So let's say I bought it from kirandevops.com. Can Namecheap issue the same? Can you create the same website with kirandevops.com? Because I bought it from GoDaddy? No, because all of these are controlled by ICANN. Just because Raggareddy RTA office gives you some vehicle number doesn't mean anyone else can also give the same IP number, same vehicle number, because they're in a different zone, right? Names should be unique across the state, or in fact across the country also. So similarly, these are globally unique. So if you buy it from GoDaddy.com, no one else can sell it, because all these people will query from ICANN. They search for the IP address, the domain names available from ICANN, and only then they can see. So if I register the website from GoDaddy.com, even if they go to Namecheap.com and type for the same website, it says no, this domain name is already registered to someone else. Okay, so why am I telling you this? Because the next hop in your DNS connection is it will go to your registrar. Registrar is the person who sells your domain names, okay, based on the available domain names from. Again, he cannot give whatever um, is available. He will search for ICANN in the ICANN database, and he can assign you. So what happens? Your DNS query is going to top level domain. From top level domain, it clearly says that, okay, I don't know the IP address, but I know where he bought it from. So you can go to this one, because when he sells the website to me, GoDaddy, let's say GoDaddy is the registrar. So he'll update in the top level domain, that is a .com server, that okay, kirandevops.com, for instance, we are searching for kirandevops.com, that is already sold out. Don't search for it anymore. I mean, don't give it to anyone else. So he will send it to registrar. So I might maintain my DNS records right here itself. Okay, I can maintain my, let's say my IP address of my server is, my website is this one. Or I might want to maintain the DNS names in my Azure DNS. Okay, I might want to maintain my own DNS, which could be on Azure, or which could be on, my on-premise infrastructure, doesn't matter. So in that case, I maintain my own DNS. In that case, I will not update my IP address here, but I will give something called as name server information. There will be some name servers for the DNS records I create here. Okay, so I will link my name server to this part. So now uh, the registrar is going to say that, hey, this person has bought the website from me, but I don't know the IP address, but I know where you can find this. Go to one of these name servers. So it will send the request to name servers, and from here, when it sends the request back, all of these places will cache the IP address. What does caching mean? Storing the IP address. And these addresses are not stored permanently, because tomorrow, let's say today I'm maintaining my IP addresses 10.110.10.15 as kiranops.com, kiranops.com, not kirandevops. Okay, tomorrow it might change due to whatever reasons. Okay, then if they have the old IP address, they're going to send you to a location where it is not anymore valid. So all these things will cache it for some amount of time, and this amount of time is known as TTL. What does TTL stand for? Time to live. Okay, meaning how long this IP address can be stored in the caching of all these systems. Okay, it will be cached at every level. It will cache at your registrar level. It will cache at your top level domain level. It will be cached at your root server. It will be cached at your ISP level. So that means if someone who is using the same ISP is accessing, he will not have to go through all these paths. First, he will go through his own router, and then from the router, it will take him to the DNS resolver, because someone else who is using the same ISP, let's say Act Fiber, he has the IP address. Someone person B who is also using Act will get it from here. He need not go all the way till here. But after 24 hours, all these things will have the refreshed ID because it is updated somewhere. Okay, so DNS is very distributed system. It works very faster, and it is cached at multiple levels. Okay, so that's why you will not see much latency. But if it's a brand new website and no one has ever accessed, it will take some time because it has to go through all the hops. Okay, even if it is cached once, but based on your TTL, typically the TTL will be 88,600 seconds, which is 1 day. So after 24 hours, obviously it will be refreshed to get the latest IP address. Okay, um, that's the DNS part. That's how your browser gets only the IP address. This is only the first part. You got the IP address. Okay, you did not get the page yet. You just got the IP address. Now, based on this IP address on the internet, your browser, now it has IP address, right? It will take this IP address and go to that particular, what someone has described as server. Okay, so it goes to a particular server. What is a server? We already talked about it, right? A server is a dedicated computing machine or a computer which runs a specific task, maybe serving web pages. Okay, but simply serving web pages is also not enough. You need to have, web page means the design and the layout, the Google logo, these things and all these things. But when I try searching, it has to have that data stored somewhere, right? For example, if I'm searching for ICANN, okay, so it has to get the list of URLs that match the search term ICANN. So that means it should also have the data, right? So where is that data stored? The list of, it should have all the list of the um, the websites. For example, if you're talking about google.com, so what is that thing called as? A database, right? You heard of the term database? So the website you're talking about not only has a web server which serves web server software which serves the web pages, it should also have database. Not only that, right, it should also have an application logic, because let's say google.com again, uh, when you search ICANN, my results and your results are differing, right? They are not same based on which user account you're using, right? Whether you're logged in or not, based on your search history from your home network, based on your user behavior or other, because Google has the information about every goddamn thing in this about your activity, right? Which sites you're accessing, which sites you're not accessing, all these things it has. So based on that, it gives you recommendations of YouTube videos and so on and so forth, right? That means there is some kind of logic
Memory.
or memory is also there, yeah. But apart from that, based on the data, when you say memory, you're talking about your data points, right? Not only that, not only simply the memory, but based on that, it is doing some computation in the background. Okay, what is the user's past behavior, which websites is most likely to visit, okay, whether he's going to, whether he's interested in Twitter, whether he's interested in YouTube, what should be given, all these things are some kind of business logic, some kind of logic that is working on. So these things we call it as business logic tier or app services. Okay, some kind of application services, like it could be a Java application, it could be a Python application, but it basically, what it does is it computes all your behavior or whatever needs to be done, and it will give you the relevant data from the database. So within this server, if you're talking, let's say if you're saying if the request is going to one particular server, that means within this server you have to run three different kinds of softwares. Okay, one is the server which one is the software which serves your web pages, which is called as your web server. Then you need to also have your business logic processing, which is your app server software. Then you have the data which needs to be stored as database. Okay, so all these three components should run on the same server if you're going to a single machine, single. But you know um, we know that it's always, I mean, from the experience, what experts recommend is it's always good to separate your app application tier from database tier, database from app server, because of some issue in database. Let's say it is taking the entire software, entire RAM. Okay, it's taking the entire RAM for itself, and now because of the database failure, even your web server is also broken, so the users cannot even see if the web page, forget about searching. Okay, they cannot even see the web page, and some error message it will give service unavailable or something like that. Instead of that, maybe you could put some better error message, right? So um, how can you, so what we need to do is, just because there is one issue with the um, one of the softwares, your entire application should not be down. So what experts recommend is separate these three softwares into three separate machines. three separate layers. Okay, so now what you do is you run only app server, web server on the first computer or the first server, and you run app server on another set of machines or another machine. Hey, can you all hear me? Mic check. And database on another
Yes,
set
sir.
of server. Okay, thank you. Okay, so here our request will go to web server. The web server will talk to, when I say talk to, will communicate with the database server. Why am I not getting the arrow? Come on. Okay, it will talk to the database server, sorry, app server, and the app server will talk to the database server, or sometimes your web server might directly talk to your app server. Okay, it's not always required that it has to go through your app server, but that is also a possibility. Okay, so this is how your applications work. This is how your applications can work, but in real time this is not how it works. Let's say how many users access your uh, you know google.com concurrently at the same time. I'm not talking about the cumulative uses, but at the same time, how many users use web Google at the same time? Just take a wild guess.
Okay, sir.
Sorry, some millions of users, right? Okay, so when I say millions of users, there are millions of transactions happening on that particular server. Okay, so let's say Google has very high and powerful computers, right? So let's say it is a, generally what amount of RAM do we have on our computers?
4 GB, 8 GB.
4
16 GB.
GB, 8 GB, these days we have 16 GB,
16.
some MacBooks and some high-end computers also have 32 GB. Okay,
Okay.
and right. So you still have, I have a Chromebook which has 1 GB RAM. There are some systems with 2 GB RAM which can still work. Okay, pretty slower but can work. Okay, and in fact, yesterday I was participating in some boot camp conference, and they asked me what was the, I mean, they're asking everyone what was the first programming language they learned. I said I learned it in my college. I learned C in my college, and the computers I used were 64 GB, 64 MB RAM, and 128 MB RAM. Don't take me for a very old timer. I did not study in 80s or 90s. I completed my college in late 2000s. I mean mid 2000s only. But still, colleges were like very. It's in a small town, so they were very. What do you call? Um, Very stingy. Very. Um, you know. Um, Very. You know, greedy. They don't want to spend much amount, so they were just using old computers with Windows 95 running on 64 GB 128 MB RAM because they think, oh, they just need to open Turbo C and run their programs, right? Nothing crazy. So from there we moved to systems with 16 GB RAM. Thankfully I have a 16 GB laptop now, but yeah, at the most 32 GB. But let's say this server, which is accessed by millions of users, has 3 terabyte of RAM. Okay, and how many CPUs, how many CPUs does our computer have, personal laptops or even work laptops? Maybe
One.
dual dual
Quad
core, very rare, quad core, right?
Duke.
And some systems, my system has high 7 and it has octa core, 8 cores. Okay, 8 cores. And maybe I'm not sure if we still have 16 core systems laptops, but I think 8 cores is the maximum. Okay, but let's say this particular computer, which is accessed by millions of users, has let's say 1024 cores, 1024 CPUs. Okay, pretty powerful, right? Or let's say 4096 CPUs, 3 terabyte of RAM, 4096 of CPUs. So super powerful, right? So that means it should be able to serve all the load to all the users, correct?
Sir.
Yeah, that is fine. Handling the load is fine. But when you work in IT infrastructure, you know that, or in IT in general, you know that your systems go down for a variety of reasons. Okay, it could be because of network card failure, it could be hardware failure, simply put it as hardware failure, or software failure, or the networking failure itself. Like, it's not able to communicate with the network for whatever reasons. It could be a hardware failure, it could be a software failure, or failure at the network level, at the because these are all connected to switches and routers and cables. So there might be some other failure. Okay, and of course these might be also connected to multiple LAN cables, not single LAN. Like, in the old days when you use a desktop computer, these days we are all using Wi-Fi, but back in the day we used to use LAN cables, right? Not sure how many of you used it. If you had a desktop, you have to plug in a LAN cable, right? But not anymore. We are using Wi-Fi, but these systems are connected to in your data warehouse, right? So all these things have multiple LAN cables. But even then, it could be some network interface card failure, hardware failure, so your entire server might go down. So if you're running your entire application on a single virtual machine, you know um, and if this crashes due to whatever reasons, what does that entail? That means the millions of users face downtime. All of them cannot see anything on the google.com website. So what, after after the initial days of using web servers, of the internet, people identified that it's good to have multiple systems running the same server. Okay, so that even if one of the system fails, the other can still handle the load. Okay, so instead of one machine with 3 TB and 4096 CPUs, you could divide this into 3 machines with each of them having 1 terabyte of this thing, and let's say, 104096 by 3 is, or let's say 4 for my convenience. That means 1.3 divided by 4 is how much? Not 1.5, 0.75 TB, and 1024 CPUs in each things. Okay, so in this way, now what you're trying to do is, instead of having a giant machine, not about the physical size, but instead of having a system with this much capability, and if we have 4 systems, you know, it will perform better, because even if there is failure in one of the virtual machine, the other systems can work. Okay, but how do we update the IP address in the domain name? For example, when we have only one IP address, web server, okay, you update the IP address of that particular web server in your DNS, right? So it will reach out to this web server. But we are saying that now we have to run the same application on not one machine but 4 different machines. Okay, all of them hosting the same software, same configuration, everything is same. Okay, same OS also maybe. Um, but how does this connection happen now? Because each system will have their own IP address. Maybe this has .16. Maybe this has .17. So which IP address to update in the DNS now? So if I update only this IP address, all the requests are always coming to here. You still have the same old problem, and with the lower capacity now because you have made it into 4 machines. So you cannot wait the system to fail and then change the DNS name, right? So what can we do here? So what can be done to mitigate this problem? Think about it. Come on, take a guess. No worries. Think you where your problem solving skills. From today, you're all DevOps engineers. Hello.
Yes, correct.
Yeah. So how do we solve this problem? Any idea?
Mm,
Okay.
Load balancer.
Why don't we put here another server which has this IP address, and okay, your DNS is updated with this server, but this server has only one work, that is to transfer your load between multiple systems. Okay. So based on, I mean, based on the rules you set, it will send data to different systems on a round robin system. I know this is looking ugly, but let me correct this one. So based on your how you configure your system, maybe on a round robin method, meaning first request will be sent to server 1, second request will be sent to server 2, so on and so forth. Okay. Okay. So you could do this, right? But what if this system itself fails? This is not doing much. There is not much load on it. Just taking the request from the server website end user and directing it to um, one of the available servers. Okay, just give me a minute, folks. Hey, I'm back. So you can put this as your what we call as a load balancer. But what if this goes down, right? This is also there is also chance of this going down, right? So hello, can you all hear me?
Yes, Kiran.
Am I audible?
Yes, Kiran. Hello?
Kiran, you are audible.
Okay, thank you. Okay, so instead this is what we call as a load balancer. So the request will come here and it will be sent to one of the available servers. But what if this goes down? There is also possibility of this going down, right? So that's why we use, instead of a server, we have highly available tools called as networking tools called as load balancers. Okay, they are like your routers. Okay, so they are like specialized and folks, remember, okay, your load balancer is also nothing but a computer only, nothing else. Okay, it also has some operating system, or your router, for instance. Okay, the router you are using, right, it is also some kind of computing device. It has its own operating system, which you can access on the browser also, right? You know, right? If you go to if you see your router documentation, it will tell you that you can access it from either 192.168.0.1. That should be your gateway IP address, or some routers give like netgear dot login dot router login or something. Okay, if you enter this website, they will show you the router web page. Okay, that means you know that there is some kind of operating system software running on in your router. When there is some software running in your router, that means it also has an operating system. Similarly, like router, you have these load balancing devices, which are specialized network devices. These could also go down, but very rarely. Okay, these are highly available tools. Okay, so you use a load balancer and the load balancer will redirect to one of these servers. Okay, all your web servers are working all the time, but what about app server? What if it fails? Okay, so similarly, you can put multiple app servers instead of relying on single app server. But how do even servers communicate with one another with IP address. So how do my web server communicate with this app server, or which app server? Let's say this is an IP address of 102.10.15.10. This has 15.11, 15.12. Okay, now in my web server configuration, I can give only one IP address to which the request can be sent. So if I want to make my application highly available, okay, what can I do to make sure that my request can be sent to any of the available servers? There are three app servers. If any of the web server is trying to reach to any of the app server, it has to reach them. Okay, so again, to solve this problem, we can put an internal load balancer. So all the load balancers, whenever they have to reach the all the web servers, whenever they have to reach to the app server, they will reach to the load balancer instead of the direct IP of the app server. Load balancer also has an IP address. Okay, so let's say this load balancer has this IP address of 15.15. So your web servers will reach out to the load balancer, and load balancer will forward the request to any of these available servers. Why am I saying available? Even if one of the server is not available, it will read out to the other servers. Okay, so um, so like this, your web servers are able to communicate with your app server. So is the case with your database servers. Okay, you could create multiple database servers, and you could create a load balancer between your database servers also. If one of the service is available, uh, your load balancer will reach out to them. Okay, so this is how you design applications, and this is called as a three-tier application. And you need not use a physical machine. You know why? Before, let's say 2000s, you had to use this model. Okay, but after 2000, uh, After around 2000s, there is this concept came as virtualization. What is virtualization? What is virtualization? Okay, very simple. It's a simple process of you know uh, dividing one physical machine into multiple virtual machines. What does that mean? Okay, let me create a new diagram. So, or again, this has also evolved from the experience, right? So initially, we used to have one physical machine. Okay, and let's say again the specs may be, mm, something like let's say 256 GB of RAM or 48 GB of RAM and um, 24 24 CPUs. Okay. So as I said in the demo class, every system has something called as firmware. In case of computers, it's called as what is it called as? You heard of the term BIOS, or these days we call it as UEFI. BIOS stands for Basic Input Output System. UEFI stands for Unified uh, Unified Elastic Firmware Interface. What is that? I forgot. UEFI stands for Unified Extensible Firmware Interface. Okay, uh, Unified Extensible Firmware Interface means this is a piece of software or rather firmware. What is firmware? Firmware is that is directly embedded on your motherboard. That is directly printed on your motherboard. It cannot be. It is not on any hardware. It is like embedded in your hard drive. Okay, so most of our modern systems has UEFI, Unified Extensible Firmware Interface, which is a way for you to configure your system. Let's say if you have multiple operating systems on the same computer, you can decide which one to boot first and which one to boot later, secure boot, initial password, everything you can set using UEFI, which is a layer below the operating system. Okay, so every computer has something known as your firmware or BIOS or UEFI. Okay, on top of it you generally install your operating system. It could be Linux, Windows, or Mac OS, or whatever it is. But again, think about the previous scenario, right? What do computer experts recommend is, if you have one OS, you have to, I mean, for the enterprise servers, you have to run only one app. You cannot run all the web server, application server, and everything in the same server. They're saying uh, it's not a right way to run. So let's say you have servers are available in various configurations. You could get servers from 32 GB or 16 GB also, but when you're spending a lot of money, why buy for such low configuration? Okay, and also if you buy more number of servers, they need more number of network cables, they need more number of cooling agents and all these things. Okay, so that means you are restricted in the, so if you have to run one application per one server, you are restricting the full capacity. It might not be always fully utilized. Okay, do is
Kiran? Hello? Kiran?
Kiran, we are unable to hear you. Hello?
Kiran, we are unable to hear.
He is unable to hear us.
Hi, Kiran. Hello.
Kiran, we are unable to hear you.
Hey, can you all hear me?
Yes, Kiran. Right now, fine.
No, Kiran. From starting of that till now, we are unable to hear you from the starting of the particular diagram. Approximately 5 minutes ago, we heard you.
Okay. All right. So what I was saying was, you have a physical server. So in the old times, when you have a physical server, right? You know, the idea is, so you have, and you know, a physical server means it also has BIOS and BIOS or UEFI. UEFI stands for Unified Extensible Firmware Interface. Okay, what it basically does is, you know, it is the firmware. Firmware means it is already printed on your motherboard. Okay, it is not like something like an operating system which can be erasable easily. uh, it is already printed on your motherboard. So BIOS, you might have heard about it, basic input and output systems. So it is the tool that will let you install operating system on your systems. Okay, it is the basic interface with which you can interact with your computer. Okay, so in the old days, what used to happen, you have a physical machine like this, ignore the diagram on the left. Then on top of it, you used to install an OS. It could be something like Red Hat Enterprise Linux or Ubuntu or you know, CentOS, SUSE, whatever operating system it is. Okay, so you have an operating system. But as I said, as per the recommendations previously we discussed, you could run only one application. Like it could be a web server or an application server software, but not both of them together on this one. Okay, because that will lead to failures. So let's say this system has high capability, because when you buy physical servers, you would like to buy systems with good capacity only, um, because they come at a cost, and also um, you know, they come at a cost, and also if you buy low systems with lower configurations, that means the physical size is same, the dimensions are almost same if you're buying a 42 GB computer or a 16 CPU or a 1 terabyte uh, computer server. Okay, but if you buy more number of systems with lower configuration, what will happen? You have to take a lot of space in your data center. That means you have to buy more real estate. The more land you have to take for the data center, right? For example, let's say if I search for Dell servers, right? Look at this one. This is a Dell Vostro or Dell PowerEdge, which is 1,92,000. So when you're buying something for 1,92,000, you don't want to buy for a lower edge, lower range of CPU and RAM, right? But again, you can run only one application on top of this one. That means a lot of CPU and RAM might be wasted. So the virtualization software is something, what it does is, virtualization software is known as hypervisors. So you have, when it comes to hypervisors, you have VMware ESXi, you have Hyper-V by Microsoft. Okay, you have open source tools like KVM and Zen. Okay, you can use any of these, one of these tools, not all the tools, of course. Let's say you're using hypervisor VMware ESXi. So what this does is it will let you divide take this physical machine and create multiple virtual machines. Okay, when it says virtual, it means it's not physical, right? So within this machine, you can run multiple virtual machines. One might be running Ubuntu, one might be running Ubuntu server, Windows Server 2019, another might be running RHEL, Red Hat Enterprise Linux, another might be running Windows Server 2016, another might be running another Windows Server 2016. Okay, or let's say something else, and each of them might be running their own applications. Okay, so in this way, with a single server, you're creating multiple virtual machines, single computer, you're creating multiple virtual machines, and you're also isolating the services. Okay, you might ask me, what happens if this entire physical server goes down? That is also a probability, but that is only the hardware failure. At the software level, since you're isolating these machines, let's say there is an issue in this Ubuntu virtual machine, only this system is affected, all the other systems are not affected. Okay, but in this earlier example, if you're using a single machine to run all the softwares, if the Java application is affected, all the other applications might also affect the entire operating system, or the entire operating system might be affected. But how do we create the redundancy? What is redundancy? Redundancy in real life means wastage actually. Okay, but in terms of computers, what redundancy means is creating a secondary system of the same capability, same configuration, same system, so that if one system fails, you have the second system where the traffic can be routed, like I discussed in the earlier classes. Okay, so for the hardware level redundancy, what you can do is replicate the same setup on another system and create multiple virtual machines on the second machine. Like just like how you created this, you replicate another machine, you take another machine and create all these machines. Now this this Ubuntu and this Ubuntu will be connected to one load balancer. So this server and this server will be connected into another load balancer. So your load balancer will send request to this and this parallelly. But what if one of them fails? If the entire system goes down, this entire system goes down, then you still have all the applications running in the secondary server. Maybe you can have 3 physical machines like this and divide these things into 3 different systems. Okay. So in the modern world of IT architecture, you use all um, virtual machines rather than physical machines. Okay, in terms of cloud, we don't even know where the physical machine, I mean, we know that they're existing in the Azure data center, but we never have access to them. Okay, we have only level at the above hypervisor, that is at the operating system level. Okay, so if I have to draw this diagram in a neat way, in a simpler way. Okay, so you understood the DNS resolution, right? So from the application perspective, 5 more minutes and we'll wind up. Okay. So what happens is you have virtual machines. So let's say we're talking about the web layer. Okay. You have, let's say, multiple virtual machines. So these are three similar virtual machines running similar operating system, running similar softwares. Maybe all of these are running Ubuntu and all of these are running Apache or Nginx web software. Okay, then there might be another set of operating systems which are running your Java application. Maybe these are also running on, let's say, Red Hat Enterprise Linux and running Java application on top of this. Okay, and then finally you might have a uh, you know database server. End users interact with the web servers. So how do they interact? Each of them have their own IP address. So I cannot put 3 IP addresses in DNS. DNS only allows me to put 1 IP address. So how do I send the request from end users to here? Using what? We discussed that. Using what? How can I distribute the load across these 3 machines?
With the load balancer.
Load balancer, right? The answer is in my question. So I use a load balancer. As I said, load balancer is a specialized networking device. Like for example, F5 has load balancers, uh, which can distribute load across multiple systems. Okay, in cloud, it's again another service you can create. So this load balancer will redirect your load to one of these virtual machines. So that means if I'm sending a request, the request is sent to one of the virtual machines, not all the 3 at once. And if someone else is accessing, okay, he might be accessing on another virtual machine. But all 3 virtual machines are running the same data, same configuration, everything is same. Okay, then you might have another load balancer which is internal to route your any requests that are made to your app server might be sent from here to here. Okay, and finally this load balancer. And maybe there is another one also internally between your SQL servers and your applications. Okay, so yeah, this has become too far. Okay, this is how your network traffic I mean, your applications are generally accessed through the internet. Okay, of course, before this, you have the DNS coming into picture. Once your DNS resolves your IP address, you know, so this is your laptop. This will go to this one. Okay, so when you have this is so three or more, you can have any number of virtual machines within the same configuration. Okay, but if you look at this one, we have, the app tier. Oops, have this app tier. We have this, sorry, a web tier or web layer, and you have your app layer or app tier, and finally you have your DB layer. Okay, okay, this kind of architecture, this is called as your IT architecture. Okay, this kind of architecture is known as three-tier architecture. What is it? Three-tier architecture. Okay, of course, before this, the DNS resolution happened. Don't forget about that. Okay, but modern applications don't only have your web server or web layer, app layer, and database layer. You need much more than that. For example, Google, when you're typing something, right? Um, you know, let's say IT architecture. Even before I type it completely, it's giving some suggestions, right? So it is kind of a quick search. So this needs a different type of database or different type of application software. Maybe it uses something called as a NoSQL database. Okay, where is this? Yeah. So maybe you have another set of VMs which is running another set of MongoDB or some other software, right? And again, each layer need not have the same set of servers. Some servers might have some layers might have more than 3 or 4 or 5 or 2 or whatever, depending upon the size. And then where we have something called as caching layer. Um, okay, so caching servers are those which will, uh, you know, query your database for the records and store them here, readily available, so that every time your web servers need not go to the database layer. They keep the uh, cache of recently accessed data in the Redis, and they will directly serve the end users from the web server itself instead of going to your DB servers. Okay, you have caching layer, you have, let's say, something like you know uh, your NoSQL layer, whatever it is. Okay, and Google, companies like Google need real-time analytics to understand your user behavior. Based on that, they will load with your, they will bombard you with the ads and all this stuff, right? So you need to have maybe another layer, which is an analytics layer. Okay, they might have some other, uh, you know, services running in a different layer. So when you have more than 3 layers, that is known as what? N-tier architecture. Okay. So most of the modern applications are N-tier architecture, and even better, these days you have something called as microservices architecture. Okay. With applications moving from virtual machines to containers, meaning each virtual machine can run multiple containers, and each virtual machine can contain all the containers: application container, web container, and you know even a database container. And this the microservices structure has really changed the application paradigm. So nowadays you might be wondering, or maybe even if you have thought, there is a lot of demand for DevOps and SRE and all these engineers. The reason being, now the focus is on modernizing the applications, containerizing the applications. So that's where Docker and Kubernetes come into picture. Okay, so um, the applications are moving more towards microservices rather than the old system of n-tier and 3-tier architecture. But there are a lot of applications which follow this architecture, and maybe in your microservices also you could call it as an n-tier architecture. Okay, so microservices is nothing but where each service is running as a separate uh, system like this. Okay. Okay, so you have something like this. Okay, you have a web app as a service, and these are all different APIs and different databases. Okay, so this is how microservices architecture looks like. More of this when we talk about Docker and Kubernetes. But just understand this is how your IT architecture looks like, and how we have abstractions using load balancers like this. Okay, this is how you can a simple application can be constructed on cloud like this. Okay, on cloud or on premise, anywhere, doesn't matter. Okay, your virtualization software can be used on your on premise machines as well. Your cloud anyways use virtualization software only. So when you when you create a computer on the cloud, it's a virtual machine, meaning there is a physical machine, but it is taking some chunk of the resources of the physical machine and creating a virtual machine with a dedicated operating system. Okay, so that's about the 3-tier and n-tier architecture. Tomorrow what we're going to see is the networking component. Okay, how these are all divided into, how do we create a network, what is a network, and how we can separate different rules for different different layers of your application, or different tiers of your application. All these things we'll see tomorrow. Okay, and including understanding what is an IP address and all that stuff. Questions?
Hello, hello,
Yeah,
Kiran.
yeah.
Can you explain me about hypervisor?
Yeah, as I said, hypervisor is nothing but it's a software. It's like a mini operating system which you install on top of your physical machines. Okay, the physical servers that you buy, and that will let you to divide your computer into multiple virtual machines. Okay, so instead of installing Windows directly on your server, you install something like VMware ESX. Okay, or Ken, or KVM or Zen hypervisor, or even Hyper-V, which is a Microsoft tool, and on top of it you can install any number of operating systems. Okay, you can divide the computer into multiple virtual machines. Each virtual machine can run their own software. That's type 1 virtualization. You have type 2 virtualization also. In type 2 virtualization, maybe you already have an operating system like Linux or Windows. On top of it you can install something like Oracle VirtualBox, or VMware workstations, or I don't remember the exact name. But what these things do is, on top of your operating system, you can create multiple virtual machines. You can create a Ubuntu virtual machine. You can create a Windows server. Okay, on so based on how big your system is. When I say big your system, based on what are the specs of your system, specifications in terms of RAM and CPU. For example, if you have a 8 GB RAM and you know 4 CPUs, you can create two virtual machines, maybe with the I'm talking about type 2 virtualization, where you already have an operating system. Maybe your operating system is already taking up 1 GB and one CPUs already. So you can create two virtual machines with 2 GB RAM and one CPU, and another virtual machine with 2 GB and one CPU. Uh, so like this, you can create two different machines. This machine can be running, let's say you're running Windows 10. You can create another virtual machine which runs Windows Server 2019, and another one which runs Windows, let's say Windows 8. Okay, you can create two different virtual machines. But in type 1 virtualization, you don't have a base operating system. You just have the physical machine and the BIOS or UEFI. On top of it, you install the hypervisor. Okay, The hypervisor is something like VMware ESXi is very popular. VMware is the company which made the virtualization popular. At the time, back in the day, I'm not sure if you're how old you were back in early mid 2000s, or even late 2000s also, meaning 2003 to 2007 8 time. Just like how there is demand for DevOps folks, everyone used to learn VMware because that was the demand. People were trying to create different virtual machines. The internet was growing, outsourcing was increasing. A lot of the European and US companies are giving the IT maintenance to India because the internet has become cheaper and easier to access anywhere. At the time, VMware was the in demand course. Everyone, just like how DevOps is in demand, everyone was learning, hypervisor tools like VMware and other things. Okay. Does it answer your question? So, if you install VMware on your physical machine, I mean, you buy a physical server like this one, Okay, this is one of these. You buy one of these servers. You connect this to at the back of it. You have the VGA cable and other connections. You can connect to a monitor, and you can connect this to a physical. I mean, to. Can you hear me?
Yes, Kiran. Here.
Yeah, you connect this to a LAN cable, and it has internet now. So when you start it on your monitor, it will simply show the BIOS. Using the BIOS option, you can install VMware ESXi, for example. Then it will give you the interface like this. Let me expand this one. Come on. Yeah, it will give you an interface like this. Using this interface, you can divide them into multiple virtual machines. You can manage the storage and also assign storage to different virtual machines. Okay, so here you might have different. Okay, so this is what a a virtual hypervisor does. Any other questions? I know we are much above our time, almost 8:40 it is. Okay, the task for today is, please note down, read about three-tier architecture and n-tier architecture. Tier, it is spelled as T-I-E-R, not tier, it is tier. Like 1-tier AC, 2-tier AC, okay? So read about three-tier and n-tier architecture, and also read about DNS. And by the way, there is a nice, beautiful video about how DNS works. The name itself is How DNS Works. How DNS works. Yeah, this is the one. Okay, so do watch this video as part of today's homework. So some ads. Yeah, interesting infographic. The same thing I told you in the class, but with interesting graphics and all that. Okay.
Okay, Kiran.
So
Thanks everyone.
Kiran,
And
Kiran, it's three-tier architecture, and one more is the n-tier architecture.
N stands for anything number. N is an integer greater than 3.
Okay, got it. Thank you.
Did I write that? Yeah, here. Okay, so tomorrow we are going to talk about networking. Bye, everyone. Have a good day or good evening.